Okay, so we're going to do question 12.8. So in this question, it's asking you to consider a two-period model with two firms A and B. So in the first period, they simultaneously choose one of the two actions, enter or don't enter the market. Okay, and the entry is going to require an expenditure of a fixed entry cost of $10. Now in the second period, whichever firms enter is going to play a pricing game as follows. Okay, so if no firm enter the market, the profit for the two firms are going to be equal to 0. If one firm enter the market, the firm will become a monopoly and earn a profit of 30. Now if both of the firm enter the market, they will engage in a competition as in the Bertrand model with homogeneous product. Alright, so part A asking you to fold the game, so using backward induction to fold the game back to the first period in which the firms are making their choice of enter or not entering the market, and write out the normal form of the game, okay, for the game. Okay, so I'll do part A. Alright, so we know that if so each of the firm will have two options, either to enter or not enter the market. Okay, so if the two firms not entering the market, then each of them is going to get 0. Alright, so the payoff, okay, in each of the case, okay, so the first case is no firm enter the market. Okay, then each of the firm is going to get 0 and 0. Right, so 0 and the payoff for the two firms. Now if one firm enter the market and the other firm doesn't, then the firm who's entered the market is going to become a monopoly and that firm is going to earn a profit of 30. Okay, so if alright, so if firm 1, okay, or firm A, okay, enter us and firm B doesn't, okay, so then firm A is going to get a profit of 30 and firm B doesn't get anything. Okay, now however, firm A will have to pay an entry cost of 10. Alright, so and firm B doesn't have to pay anything because firm B doesn't enter the market. So therefore the payout for firm A is going to be 30 minus 10, which is the entry cost. Okay, and the payout for firm B is going to be equal to 0. Right, firm B doesn't enter the market, so firm B doesn't get anything, however doesn't earn anything either. Alright, so therefore the payout is going to be 20, 0. Alright, now if firm B is going to enter the market, okay, and firm A doesn't, then again very similar situation, firm B is going to earn $30 profit, however has to pay $10 for an entry fee, and firm A would not have to do anything, would not have to incur anything, however doesn't earn anything either. Okay, so therefore alright, so I would just put firm A over here. Okay, so does not enter the market, right, and firm B does. Okay, so firm A is going to get 0 and firm B is going to get 30 profit minus 10 of the entry cost, and so therefore the payoff is going to be 0, 20. Okay, and in the last case, both of the firms are going to enter the market. Now, if that's the case, then the question telling you that they are going to engage in a competition just as in the Bertrand model, okay, with homogeneous products. So they're basically selling exactly the same products, okay, and okay, so given that okay, the two firms are selling homogeneous product. Okay, and they compete in Bertrand competition. Now Bertrand competition is where the firms are competing in price. Okay, So basically they are choosing a price in order to maximize their profit. And if the two firms are selling exactly the same thing, which basically means assuming that they're going to incur exactly the same cost, then if they compete in Bertrand competition, the price they are going to charge at the end in equilibrium is going to be equal to their marginal cost. Okay, and each of the firm is going to end up having zero profit at the end, because whoever charging a higher price is going to end up losing the whole market to the other firm. Okay, remember, because they are selling exactly the same products and having exactly the same costs, so therefore whoever charging a higher price is going to lose the whole market to the other firm. Right, so therefore in the equilibrium under Bertrand competition, the two firms are going to charge the price. Okay, so two firms, okay, it's going to charge a price equal to the marginal cost, and therefore they are going to make zero profit. Okay, so therefore the two firms are making zero profit. However, they still have to pay the entry fee of 10 because they decide to enter the market. Alright, so therefore the payoff is going to be 0 minus 10 for the first firm and 0 minus 10 for the second firm. Okay, so therefore it equals to negative 10 for the two firms. Alright, so we already derived all of the payoffs in each of the cases. Now we are going to be able to have a normal form 2 times 2 matrix for the game. Okay, so over here I will have firm B, and over here I will have firm A. Alright, now firm B is going to decide between entering the market, okay, or do not enter the market. Very similar for firm A is going to decide between entering the market or not entering the market. Okay, so now we just have to fill out a payoff over here. So if the two firms are entering the market, we found out each of the firms going to get negative 10. Now if firm A enter the market and firm B doesn't, then firm A is going to get 20 while firm B is going to get 0. So very similar over here. If firm A doesn't enter the market and firm B does, then firm A is going to get 0 and firm B is going to get 20. And if none of the firms going to enter the market, each of them is going to get 0. Alright, so this is the matrix, the payoff matrix for the game. Okay, so part B asking you to find the mixed strategy equilibrium of the game. Alright, so in order to find the mixed strategy equilibrium, bear in mind that the mixed strategy equilibrium means the two firms are going to play the mixed strategy, okay, which is basically means that they are not going to either enter the market or not enter the market with 100% sure. Okay, they're going to enter the market with a certain percentage of time, and they're going to not enter the market with a certain probability. Okay, so therefore what I do is I'm going to let X be the probability that firm A is going to enter the market, and 1 minus X is going to be the probability that firm A doesn't enter the market. Okay, so very similar, I will be putting Y over here as a probability that firm B is going to enter the market, and 1 minus Y is the probability that firm B is not going to enter the market. Okay, so so I'll say let X be the probability that firm A enters the market. Okay, so 1 minus X is going to be the probability that firm A doesn't enter the market. Okay, now again Y is going to be the probability that firm B is going to enter the market. Okay, and so therefore 1 minus Y is going to be the probability that firm B doesn't enter the market. Alright, so Okay, so what we need to do now is to find the values of x and y in order to find the mixed strategy equilibrium. Okay, so first of all, we are going to consider player, or consider firm 1 or firm A payout first. Okay, so now we are going to see what is the expected payout for firm A if firm A is entering the market. Okay, so if firm A decides to enter the market, what is going to be firm A's expected payoff? Okay, so expected payoff for firm A by entering the market is going to be equal to, now we're looking at the table, the matrix payoff, the payout matrix over here. Firm A decides to enter the market, that is going to be the first row that we should be looking at. Okay, now so depending on what firm B is going to do, firm A is going to get a different payoff. Alright, now firm A is going to get -10 if firm B decides to enter the market, and firm A is going to get 20 if firm B decides to not enter the market. Okay, so therefore with the probability of y, firm B is going to enter the market and firm A is going to get -10 by entering the market. And with the probability of 1 minus y, firm B is going to not enter the market, and therefore firm A is going to get 20 by entering the market. Okay, so therefore the expected payout for firm A is going to be the probability of y, firm A is going to get -10, and the probability of 1 minus y, firm A is going to get 20. Okay, so if I expand all of the brackets and simplify, I'll get 20 minus 30y. Okay, now by not entering the market, what would be the expected payoff for firm A? Okay, so firm A not entering the market, we should be looking at the second row of the payout matrix. Okay, in which firm A can either get 0 or 0 over here, so it is the same. Okay, so it doesn't matter whether firm B is going to enter the market or not, firm A by not entering the market always going to get 0. Right, so expected payoff is going to be equal to 0. Alright, so now in order for us to have a mixed strategy equilibrium in which each of the firm is going to apply a mixed strategy, then the expected payout for firm A by entering the market has to be equal to the expected payout for firm A from not entering the market. Okay, now the reason for this is because if one strategy is giving a higher payout than the other strategy, then the firm will apply a higher payoff strategy for sure without any probability. Okay, so therefore we are going to get a pure strategy equilibrium, not a mixed strategy equilibrium. Okay, so in order for a player to randomize on the two strategies or to apply a mixed strategy, then these two payoffs from the two strategy will have to be the same. Okay, otherwise if one is bigger than the other, then the firm is going to apply the strategy that gives a higher payoff. Alright, so I'll say in order for firm A to randomize on two strategy, okay, or to apply a mixed strategy, then it has to be the case that expected payout for firm A from entering equal to expected payout for firm A from not entering. Okay, so therefore 20 minus 30y has to be equal to 0, and so therefore y is going to be equal to 2 on 3. Alright, okay, so we're done for the first firm. We're now going to consider the second firm. So consider firm B's payoff. Okay, so again, by entering the market, what is going to be the expected payout for firm B from entering the market? Alright, so firm B, by entering the market, we are going to look at the first column of the payout matrix over here, where it's possible for firm B to either get -10 over here or 20 over here by entering the market, okay, depending on what firm A is going to do. Now if firm A decides to enter the market, firm B is going to get negative 10 by entering the market, and if firm A decides to not enter the market, firm B is going to get 20. Okay, now so as you can see, with the probability of X, firm A is going to enter the market, and therefore firm B is going to get negative 10. With a probability of 1 minus X, firm A is going to not enter the market, and firm B is going to get 20. Alright, so therefore the expected payout for firm B from entering the market is X times negative 10 plus 1 minus X times 20. Okay, so that is 20 minus 30X. Okay, now by not entering the market, then firm B, by not entering the market, we are going to look at the second column of the payout matrix. Now as you can see, firm B, by not entering the market, is going to get 0 either way. It doesn't matter whether firm A is going to enter the market or not. Firm B will always going to get 0. Okay, so again, in order for firm B to randomize or to apply a mixed strategy, then it has to be the case that the expected payout for firm B from entering the market equal to the expected payout for firm B from not entering the market. Okay, so 20 minus 30X equal to 0, and so therefore X is equal to 2 on 3. Alright, so we found the value of X and Y. We now will be able to confirm the mixed strategy Nash equilibrium. Okay, so mixed strategy Nash equilibrium is where the two firms are applying mixed strategy with a probability of X equal to 2/3 and Y equal to 2/3. Okay, alright. Okay, now Papasi asking you to compare the result from the mixed strategy Nash equilibrium to the Bertrand paradox. Okay, so first of all, we will have to know what is the Bertrand paradox. Okay, the Bertrand paradox is basically the situation in which the two firms are competing in price and going to end up charging a price equal marginal cost in the Nash equilibrium. Okay, so basically the two firms are ending up making 0 profit under Bertrand competition in the equilibrium. Okay, so this is the situation in which two firms charging the price equal to the marginal cost in equilibrium. Okay, so this means that the two firms are making 0 profits in equilibrium. Okay, the two firms makes 0 profit in equilibrium. Okay, so now how is our mixed strategy Nash equilibrium is going to be similar to the Bertrand paradox. So we will just have to find the expected profit that each of the firm is going to get in the mixed strategy Nash equilibrium. Okay, so from the previous part, from part B, we found that the mixed strategy Nash equilibrium is for firm A to play is for firm A to enter the market with a probability of 2/3. Okay, so firm A enter the market with a probability of 2/3 and not enter the market with a probability of 1/3. Okay, so very similar for firm B. Firm B is going to enter the market with a probability of 2/3 and not enter the market with a probability of 1/3. Okay, so we now just have to find the expected profit for the two firms. Okay, so expected profit, okay, for firm A. Okay, so I'll say expected profit, okay, for firm A. Now, have sorry, 2/3 of the chance the firm is going to enter the market. Now, if the firm decides to enter the market, it's have two cases that are going to occur. If the firm decides to enter the market and the other firm also decides to enter the market, then firm A is going to get -10. Okay. Now this is going to happen with a probability of 2/3 because firm B is going to enter the market with a probability of 2/3. Okay, so therefore given firm A is entering the market, 2/3 of the chance firm B is going to enter the market as well, and if that's the case, then firm A is going to get -10 as a payoff. Okay, so this is the probability. Okay, that firm A enter the market, and this is basically the probability that firm B enter the market. Okay, so if two firms are entering the market at the same time, then the firm A is going to get a payout of -10. Now, if firm A enter the market with a probability of 2/3, however, firm B decide not to enter the market, as we say over here, firm B in equilibrium is going to not enter the market with a probability of 1/3. Okay, so if that's the case, then only firm A enter. Okay, and firm B doesn't. Okay, if that's the case, then firm A is going to become a monopoly and firm A is going to get a profit of 20. Okay, so alright, so we're done with the probability of firm A entering the market. Now, 1/3 of the chance firm A is not going to enter the market, and as we already showed earlier, if the firm doesn't enter the market, it is going to get 0 either way. Okay, anyway, so therefore the profit is going to be equal to 0. Right, so you add all of these things up, you can see that the expected profit for a firm is going to be equal to 0. Okay, and that is exactly what it is said in the Bertrand paradox, that in the end the two firms are going to end up with 0 profit. Okay. Now, so if you want to do, you can do exactly similar for firm B. So we just have to find the expected profit for firm B. Okay, with all of the alright, so this is very similar to firm A. Now firm B decides to enter the market with a probability of 2/3, and 2/3 of the chance firm A is going to enter the market and firm B is going to get -10. Now 2/3 of the chance firm B is going to enter the market, however firm A decide not to with a probability of 1/3, and so therefore firm B is going to become a monopoly and earn a profit of 20. Okay, and 1/3 of the chance is going to be equal to 0. So again, the expected profit for firm B is 0. Alright, so therefore we say that the mixed strategy equilibrium basically consistent with the Bertrand paradox in the sense that the two firms are going to make a 0 profit at the end. Okay, in the equilibrium. Okay, so I'll say the mixed strategy equilibrium is similar to the Bertrand paradox. because the two firms are getting zero profit. Okay, as in the Bertrand paradox. Okay.